So today we're going to be learning about ocean acidification. And before I go into our lecture, I just want to review a few key concepts that we learned in a previous lecture that'll be important for the concepts we're covering today. So if you remember from one of our last classes, we discussed pH. And pH is a measure of how basic or how acidic a solution is. If something is more basic, it has a higher pH, and if something is acidic, it has a lower pH. And if you recall, the definition of pH is the negative log of the hydrogen ion concentration. And this is important because these are inversely related. So the more hydrogen ions you have in a given solution, the lower the pH, or the more acidic. So if you have an increase in hydrogen ion concentrations, you have a decrease in the pH. And this will be important to keep in mind for our lecture and demonstration that I'm going to do today. The other important concept besides pH that will be very important for ocean acidification is understanding chemical equilibria. So with our demonstration here, for example, we're going to have a simulated atmosphere and ocean. And any solution that's in contact with a gas in its surrounding environment will eventually come into some kind of chemical equilibria. And that goes for other substances as well. But in this case, we're going to be talking about our atmosphere and the ocean. So in the case of our atmosphere and the ocean, over time, the surface ocean and our atmosphere, with respect to the carbon system, but also many other parameters, will come into equilibrium with each other. But what we'll notice with this demonstration is that if some disequilibrium happens, then a new equilibrium will have to be established. So keeping in mind our concepts of pH and also chemical equilibria, we're going to dive into this demo here, which is going to introduce us to ocean acidification. So what I have here is a simulated ocean, as I mentioned, represented by this blue liquid here shown in the tank. The atmosphere is the surrounding air in the tank. Then I also have a little bowl that's upside down in here that's going to represent the land in our system, and we can think of this as a simulation of our Earth system. It's a blue color because I've added a pH indicator dye shown here. This is the pH chart, which you can notice. So if our system is at a neutral pH, the liquid will be blue, as you can see here. I've used tap water for this demonstration, but we could have used seawater as well. Does anyone know what the pH of seawater is on average? That's right, it's very close to neutral, but on average it's about 8.1. So it's a little bit more basic than some of our tap water. So our tap water here is about 7, which is why it is this blue color. Now in our demo, if it starts to become more yellow, that will represent the solution becoming more acidic. So keep your eye out for any changes that might be happening in our demonstration here. So as I mentioned, we're going to use tap water, but it's going to simulate our ocean. And now what we're going to do is add some dry ice. Now, dry ice is frozen CO2. And this frozen CO2 I'm going to place onto our land system in our demo here. And we can make some observations. But this dry ice, since it's frozen CO2, is going to represent the burning of fossil fuels in our atmosphere. So what are some of the things that you're noticing? Well, yes, that's right. You can see that the CO2, the frozen CO2, is turning into a gas. So that represents the CO2 in our atmosphere. And as you might have guessed, this is causing a disequilibrium in our demonstration here, where the CO2 is now building up in the atmosphere. And so because of that, it must go in to our simulated seawater and try to, as it's coming into equilibrium. And if you notice, that happened in the surface of our simulated ocean first. And so in seawater, if we imagine this is the surface of the seawater, we have CO2 in our atmosphere from fossil fuel burning, but also present naturally. It has to come into equilibrium with the surface ocean, and when it goes into the ocean, it combines with water to create carbonic acid, which is shown here. And as you might have guessed from the name of just this first inorganic carbon species, it is an acid. And this dissociates further into a hydrogen ion plus bicarbonate. and then this further dissociates into an additional hydrogen ion and carbonate. And so what have you noticed now about our seawater system? If we look at it, it's drastically changed color and now it's yellow, so it's become more acidic. So what are some of the hypotheses as to why that might have been the case? That's right, since the CO2 has dissolved now into the seawater, it created this carbonic acid, which then creates one hydrogen ion in this first process, and then in this other dissociation, another hydrogen ion. So 2 more hydrogen ions were produced with the CO2 dissolving just from this one. So if we come back to what we learned about pH in our previous lectures, we learned that more hydrogen ions will decrease the pH of the seawater. And so this is showing exactly why this has happened here and why our system is now yellow. So even though we've just introduced that here, I just want you to keep this demo in mind when we're going forward talking about ocean acidification in our lecture today. And we're going to have 3 key concepts that we'll cover. The first concept, which we demonstrated nicely here, is that the chemistry of the ocean is linked to the chemistry of the atmosphere. And so we demonstrated that both here with this demo and also with going over some of these inorganic carbon equations. The second is that more CO2, or carbon dioxide, in the ocean makes the ocean more acidic. And this is the root of ocean acidification that we'll go into more depth today, and also what we've reviewed here. It creates these hydrogen ions, which is why the ocean becomes much more acidic. And finally, which we haven't discussed yet, is that a more acidic ocean affects marine organisms. And this is a very important component of ocean acidification and why it has received so much media attention lately. Maybe you've heard a little bit about it. And although we haven't discussed that yet, I would like you to discuss with your partner or a few neighbors sitting around you what you think some of the effects on marine organisms might be, given that the ocean is becoming more acidic, especially in the surface ocean, which you might have noticed in the beginning of the demo, as the surface is the first to equilibrate with the atmosphere. So please discuss this key concept with some of your neighbors, and then after that, we will go into our detailed lecture today about ocean acidification.